Okay, so now we're going to be using those same exact problems, but we're going to be answering some questions or finding some terms within the sequence. So, you have a cafeteria card that's worth $50. After you buy lunch on Monday, the card value goes down to this. After you buy lunch on Tuesday, the card value goes down to this. And that sequence continues. We want the value of the card after you buy 12 lunches. Well, on term 1, which is $50, how many lunches did you purchase? None. 0. Because your card was just loaded with $50. Term 2 of your sequence was when you purchased 1 lunch. Term 3 of your sequence was when you purchased 2 lunches. So what term would you have after you buy 12 lunches? Well, if you notice, the number of lunches is 1 lower than the term number. So if I want 12 lunches, I'm really trying to find the 13th term. So in my explicit formula, which was, let me remind you, A of n is equal to 50 minus 325 times n minus 1, we want to put 13 in for n. We want to find the 13th term, which would be when we purchase 12 lunches. Remember, A of 13 is just telling us that we're finding the 13th term here. So I'm going to have 50 minus a 325 times a 12, which I can just type in my calculator. 50 minus 3.25 times 12, and I would get $11. All right, next problem. An accountant starts off with a base salary of $53,000. Their salary increases by $2,000 each year. Find the accountant's salary if he/she has been working there for 6 years. So a reminder that, let's write a little bit of our sequence. 53,000. And the next year it would be 55,000. Next year would be 57,000, and so forth. In year 1, we made 53,000, and that was term number 1. So in year 2, or term 2 represents year 2. Term 3 would represent year 3. So if we want year 6, since the term number is matching the number of years, we want the 6th term. So what we're going to do is we're going to use that formula, that explicit formula of A of n is equal to 53,000 plus 2,000 times n minus 1. Remember, we already wrote that formula, but now I'm going to put 6 in for n. I'm going to find the 6th term. And then, remember, A of 6 just means I'm finding the 6th term. So I really have 53,000 plus 2,000 times 5. And I can just put this into my calculator. A 53,000 plus a 2,000 times a 5 will get you $63,000. So if this accountant works at this company for 6 years, they will be making $63,000. Now it says, what year will he/she be making $93,000? So what we do here is, n, remember, represents the number of years. So what we want to do is we want to put 93,000 in for A of n. now I want to find n. This is just a simple equation. I'm going to first distribute the 2,000 in. I'm then going to combine like terms. I'm then going to subtract this 51,000 over. And then I'm going to divide by 2,000. And I wind up with n is equal to 21, which represents our term number. And again, since the term number equals the amount of years, then that is our answer, 21 years. So in 21 years, this accountant would be making $93,000. All right. Suppose you want to make a reduced copy of a photograph that has an actual length of 8 inches. Each time we press the reduce button, the copy is reduced by 12%. What is the length of photograph copy if you press the reduce button 5 times? Remember, this means that we're decreasing by 0.88. So, if I start at 8 inches for my photo, if I do 8 times 0.88, that would give me my second term. And then if I multiply by 0.88 again, that would give me my third term. And so forth. Now, it's very easy to hit the reduce button 5 times and use the recursive formula for this one, but I actually want to explain this one using the explicit formula right now. So, the first term of your sequence was when you pressed the reduce button 0 times. The second term of the sequence was when you pressed the reduce button once on the copier. The third term of your sequence was when you pressed the reduce button twice. So if we want to press the reduce button 5 times, again, the number of times that you press the reduce button is 1 less than the term number. We are really looking for the 6th term of the sequence. So what we really want to do is put 6 in for n. And remember, the formula was 8 times 0.88. And then to the n minus 1 power, so in this case, the 6 minus 1 power. I'm simplifying from here. This would be an 8 times a 0.88 to the 5th power. And now we can type that into our calculator. 8 times 0.88 to the 5th power. And it does say to round to the nearest hundredth. So it's going to be about 4.22 inches after you press the reduce button 5 times. All right, moving on to the next problem here. We have the starting salary of a company is $42,000 per year. The company automatically gives you a raise of 3%. What will you make after you work for this company for 4 years? Now you are more than able to do the recursive formula here if you wish. I'm going to show you with the explicit formula. So a reminder with this one, I have A of n is equal to 42,000 times 1.03 to the n minus 1 power. This is your first term, 42,000. That's also what you made in year 1. So the term number matches the number of years that you have been working at the company. So if you've been working at the company for 4 years, we want to find the 4th term. So we're going to put 4 in for n. And just typing this into my calculator, $42,000 times 1.03 to the 3rd power, because a 4 minus a 1 is a 3, we would wind up with about $45,894.53. lessons. All right, looking at number 5. A reminder for this problem, we started with 1 bacteria and we doubled every hour. We want to figure out how many bacteria we will have by the end of the day. Now, if we started, here's my sequence, 1, then times 2 would be 2, then times 2 would be 4, and so forth. Now, the first term was 1. This was at the very beginning of the day. An hour did not pass, so this was after 0 hours passed. My second term was after 1 hour passed. My third term was after 2 hours passed. And we want by the end of the day, which means 24 hours. So we want after 24 hours passed. The number of hours is 1 less than the term number. So we were really trying to find the 25th term of our sequence. So we're going to put 25 in for n. And if I do 1 times 2 to the 24th power, because a 25 minus a 1 is a 24, I wind up with 16,777,216 bacteria. All right, number 6. A reminder that for this one, we started with 128 participants in our tournament, and every round, half of the teams are eliminated. So what happened was, here's our sequence. We start with 128. This was term 1, which 0 rounds have been played at this point. And if I do 128 divided by 2, I get my next term, which is term 2, and that was after the first round has been played. So if we want after 5 rounds, the number of rounds is 1 less than the term number, so I want to find the 6th term of this sequence. So I'm going to put 6 in for n. And if I type this in, this is going to become the 5th power. A 128 times 1/2 to the 5th power would give us that there are 4 participants remaining after the 5th round. And again, you could use the recursive formula to check. On this one, we can easily now do 64 divided by 2 to get the 3rd term. Then that's 32 divided by 2 to get the 4th term is 16. Divided by 2 to get the next one is 8. Divided by 2 to get the 6th term, or 5 rounds, is 4 participants. So that works. And then our last problem, we have a child putting $1 into a piggy bank. Then the next week, 125, then the next week, 150, and so forth. All right, remember this was the formula A of n is equal to 1 plus 0.25 times n minus 1. We want how much money does he put in the bank on the 25th week? Well, all right, term 1 was week 1. Term 2 was after the first week, which means the 2nd term. So the term number is matching the week number, so if we want the 25th week, we're going to put 25 in. And typing this into my calculator, we get $7. That brings us to the end of this lesson.